Would you look at that? That is a nice looking title screen. I used a marker for it. I'm pretty excited. Today we're going to figure out, are we going to multiply or divide? We're going to use inputs and outputs, which you guys used in 5th grade for show. And also I'm going to help you with it. So we're going to do probably like one together or so. And we're going to see how it goes. When you're trying to figure out whether to multiply or divide, like in life, usually it's pretty easy because you can hold things and look at them. Sometimes when we read, it might be a little bit harder. And so I'm going to show you how to use those input-output tables from 5th grade. And they're going to help us see the relationship and figure out whether we multiply or divide. So for the purpose of figuring this out, we're going to start here at Laura. We're going to start with Laura. She's baking a cake, and she uses 1 3/4 of a cup of flour for each cake she bakes. So something to think about right here, when it says each cake, that just means there's one cake. So that's kind of a hidden number. It's a little tricky. It says she only has 10 cups of flour. So again, there's more flour. And it says, how many blank will Laura be able to make? So if we look here, she starts with 1 3/4 cups of flour. So one way you could do this is you could draw a picture, right? So you could say 1 cup and then like 3/4 of a cup. And together she could use that to try to get to 10 cups, right? And at 10 cups she's going to run out. So we're trying to find how many 1 3/4 cups she can use to make 10 cups, right? So you're seeing that we don't have a number here, right? 1 3/4, we don't know how many of these we're going to need to make 10 cups, right? And so essentially we can kind of see what the gap is here. So how many blank will she be able to bake? Well, what is she trying to bake? A cake. So we're looking for the number of cakes, right? And if we look on a table, we're just going to be thinking about the two things that we're comparing. So here we would say we start with a cake, and depending on how many cakes we make, that's going to determine how much flour we need. So we could say 1 cake would need 1 3/4 cups of flour. So if I had 2 cakes, how could I find how much flour, right? So we could say 1 cake turns into 2. So we could double the amount of flour, right? Or we could say, you know what, we're trying to get to 10 cups of flour. How many cakes can we bake, right? So here I can see that I'm missing the number of cakes, right? That's going to be what I'm looking for. I could keep counting by 1 3/4 until I get to 10. I don't know if it's going to hit 10. So instead what I can look at is, rather than changing 1 3/4 into 10, I can actually use that relationship between cakes and flour, right? So I'm starting with the 1. I'm turning that into 1 3/4. And if this was an easy number, so if it was like a 2, I could say 1 times 2 makes 2. Or if this was a 5, I could say 1 times 5 makes 5, right? Because 1 times any number is going to make that number. So I know that 1 times 1 3/4, right, is how I'm going to get from cakes to flour. So that's my relationship, right? If I came down here and I tried to move from this number to 10, so x times 1 3/4 should make 10, I can't do that because I don't know what x is. So instead, I'm going to start with what I know. I start with the 10, and I'm going to work backwards, right? So instead of multiplying by 1 3/4, I'm going to start with my 10, so I'm going to actually divide, which is the inverse of multiplying, by 1 3/4. And this is super, super important that I start with the 10. Because when I divide, right, especially with fractions, the easiest way to do that is to take this 1 3/4 and instead of dividing it, we're actually going to multiply by its reciprocal. right? So first things first, I'm going to look at that 1 3/4. I'm going to change it to an improper. So 1 times 4 is 4 plus 3, 7. And I'm going to start with that 10, right? So 10 divided by 7/4. If I put the 10 over 1, 10 divided by 7 doesn't work. 1 divided by 4 is going to give me a really small number. So instead we're going to rewrite it. This 10 over 1 times, and this whole thing here is going to flip, right? So when we divide by 7/4, it would be like multiplying by 4/7. It's going to give us the same answer. I'm kind of running out of room here. I'm just going to go ahead and finish it out right here, and then I'll kind of use the space. So 10 times 4, 40. 1 times 7 is 7. And then we can just kind of take this up here. We can do a little 40 divided by 7. 7 goes into 40 5 times. There's 5 left over. So I could say 5 cakes with 5 pieces out of 7 left over. So here, oh boy, 5 5/7 cakes. Oh my gosh, I'm so embarrassed. I've totally run out of room. So 5 5/7 cakes is how many she could actually make. We wouldn't probably make part of a cake, so she would just make 5 cakes. This is a lot of work. What I would suggest is if you're working through these, input-output table is always going to work. It's going to show you the relationship. Some of you guys are more visual, and that's totally cool, right? So if you want to, instead of be organized using inputs and outputs, you can basically draw a picture, but there should be some kind of proof here, which is going to show you where to start, and then how you're going to change it to get to your answer, okay? I think with the rest of these, you should be fine. Just use this as your example. I'll go ahead and post an answer key, which should help you guys just know if you're getting them right or wrong. Good luck, dudes!